Okay, we're going to talk about chapter 8, a good chapter to read, not the easiest chapter, in dealing with proportion. And proportion deals with ratios and size relationships. Okay, so you've probably noticed you've drawn a box or a cylinder, and it might have looked too thin or too wide, too short, something like that. This is a technique on how to deal with that. So here we have some heights and widths. And the one at the top we'll call, you'll notice there's a lot of ones, 1 to 0.5. So we'll call it the unit of measure 1, and that's the height. So all of these are the height is the 1, and then the rest is how wide it is compared to the height. So 1 by 1/2 of 1, 1 by 2, so forth and so on. If you've ever put anything in like a Xerox machine and enlarged it, say instead of it was at 100% and now you're taking it up to 164, you're doubling the size, it's always within proportion to itself. And that's the idea of this slide. So it's sort of the Tonka truck or whatever, the toy truck. If you're taking it small and scaling it up, everything has to be in proportion. You can't have humongous wheels on a little bitty truck or a humongous truck with itty bitty wheels, etc. And so the idea is scaling up in size in this particular slide. We're going to be using a sighting method. It's much like checking angles. You'll put your arm out. And the video should help with seeing this. You can do it with your arm bent. It's difficult to do that and hold your pencil in the same spot, but it is doable. So this jug, if you notice, the 1 is our unit of measurement. Again, you could call it Fred or Sally, but 1 is what I always stick with. You will put the end of your pencil up to one edge and move your hand over to the other edge to create 1. So there is 1, right? And then you will move up using that same unit of measurement. And in this particular case, it says 1 7/8. You're not going to get as specific as 7/8. You'll say, okay, the height is a smidgen shorter than the width. You could do this with a whole still life as well. So here's 1 from edge to edge. Then you measure up, and you'll see the height is 2/3 of the width, roughly. If you did the height and decided that's going to be your starting point and went from 1, then it would be 1 by 1.5. I would stick with probably height the whole time. This is kind of the idea of size constancy. So this is the same object in different places. So as objects go back in space, they get smaller. But if it's, for instance, this jar of whatever gooey liquids, probably Winsor Newton stuff, the closer it is to you, the larger it is, but it will be in proportion to itself the further back that it goes. With a cylinder, when you go to measure the width is always the same if you turn the cylinder, right? You could turn it and it's always going to be the same width. So there's nothing to worry about in that particular case. With something like this masking tape, it's going to be a little, even though it's a cylinder, it changes as it goes back in space, but not that it gets smaller. Look at the height of it. The one closest to you, the top part of it, you see more of the top of it, and then you see less as it gets closer to eye level and moves back in space. The same thing sort of here. The height is staying the same, but changing with whatever angle that you place the masking tape. So certain types of cylinders change width. If it's a cylinder like this, if it's laid down, maybe the width is the same, but the height becomes different. Some of this really isn't that important. It's just kind of good to know information. This is another slide dealing with the idea of size constancy. I've already talked about that. So here we are with a series of windows. Okay, there's our 1, our height, 1, 1, 1, 1, 1, 1 to 1, 1 to about 3/4, 1 to half, 1 to about 1/4, 1 to a little bitty eighth. Oh my gosh. Okay. Okay, so in other words, don't stretch out the window to make it, or a rectangle to make it sort of fit what you think it should fit. You're going to have to use your clock angle tool. And the idea is oftentimes you have to shorten that distance more than you think that you should when it's one of these types of objects. And of course, it's always good to remember, as something goes back in space, not only does it get smaller, but it gets lighter. So here's some great examples of sketchbook work. And these are doors and windows at different angles and eye levels. All of these are below eye level, I think, except for one. And you can either, I see this as more of like checking angles and proportions. So you could fit like 10 doors on one page if you decided to do this. This is a good exercise. And another example, several different doors from different angles. Doing this in your sketchbook, if you do this in your sketchbook and upload it, I will definitely give you extra credit. It's such a good exercise. If there's a hallway, for instance, in a dorm or an apartment building, you could draw this and you see that door is the same door over and over again. It's just, it gets smaller, but the angles stay the same. So the width of the door changes. If you get below eye level of a door and then draw it and practice your height times width, this is such a great exercise. This should be what we do. I have no idea what this slide means. You can, depending on where you start to do your measurement of one or Fred or Sally, depends on how the rest of it turns out. I would generally stick with width times height. Sometimes you can go height times width. In this particular case, they're saying from the top of the bottle to where the neck of it kind of ends is 1, and the rest of it is like 1 3/5 of that. Or on the right hand side, if you went from the bottom to that, this seems kind of confusing. Let's just keep it simple. In this particular one, this isn't a bad way to go either, because you may need to get like the width of a like a top of something that may be different. For instance, here, the jug, the opening, I can't think of the name of this thing. What is it? A neck, an opening, a top, something like that. You could measure that as 1 and then go across, and that would be helpful for later in portraiture or something. But hopefully with the videos, you have some idea of proportion now.